Hi, thanks for clicking Introduction to Functions. My name is Mateo Piper. Together we're going to take a moment to step through and explain what a function is, and I'm going to try to convince you of something by the end of the video. This video was made with the intention for students who are taking Math 125 and for students who are preparing for the ALEKS test. It's also prepared for students who are just looking for a brush up on some of these basic math skills that you're expected to be having as you're climbing through our classes here at Washtenaw Community College. So without further ado, we're going to step right in. This is Introduction to Functions. So if you aren't familiar with what a function is, that's totally okay. Part of this video is we're going to be talking about that. I'm going to take us through three things to help us understand what a function is. The first thing I'm going to step us through is to describe the equation. We have an equation that might look something like this. The second thing we're going to talk about is a table view. So we're going to see something like this, an x, y, and then some rows. And then the third thing we're going to talk about is the graph that follows this function, which is going to look something like this. And what I'm going to try to convince you of is that this right here, that function, that equation, is the same thing as this shape with this curve here. So without further ado, let's begin. But since you're in Math 125, you've already been presented with what an equation is, and this might look a lot like an equation. So I want to just take a moment to clarify what's really the difference here. Well, with a function, you might see the notation look something like this. F of x equals x squared. You might also see the notation exactly like what I've written inside number 1 here with y equals x squared. A function and an equation look pretty similar. Like I said earlier, you're already familiar with what equations are. You saw a very basic problem that you were expected to solve in this class that looked a lot like this, except we had numbers on the other side. We saw something like y equals 10 plus 6, for example. And if we wanted to solve the equation, you might have seen a command for that. You might have saw a command that said something like solve for y, right? So how would you solve for y? Well, you would add both of those numbers together. We get y equals 16 as a result of doing some basic algebra, right? A function is slightly different. Instead of trying to execute a solve for y, what we're trying to do with a function is we're trying to get you to think about how x relates to y. So if you're looking for a command, it might look something like relate x to y. So how do we go about doing this, though? Because it looks different than doing some basic algebra to solve for what our missing variable might be. Well, that's what brings us to number 2 here. So we have a table view that's going to give us the answer to how we move from this equation in number 1 to that shape in number 3. And the way that we want to set up this table, especially if you're newer to this and this is a newer idea to you, we're going to set up our table in this way. We're going to write our x, and then we're going to draw a line, another line underneath, and we're going to go ahead and rewrite our equation that we were given earlier. Y equals x squared. You might hear some instructors talk about this as an input and an output. We use those terms, and it'll become clear in a moment why we do, but it's important not to forget this for your quiz or your test, that these are also inputs and outputs. But to finish building the table, what we want to do to get this shape in number 3 is plot some points. So we're going to start with a -2, a -1, a 0, a 1, and a 2. We're calling these inputs because when we're looking at the function, this is the value that we are going to plug in, so to speak, for x. We're going to substitute this value in for x. And the number that we get as a result of putting that value in for x is going to give us an output value. So we have this relationship, right? Our call from the very beginning was to relate x to y. This is how we're starting to set up describing that relationship. So let's look at this -2, for example. If we wanted to figure out what the output is for an input of -2, we would rewrite the line something like this. Y equals -2 squared. So all I did is I put that -2 that we saw for x, I substituted that in for where I saw x in my function, and then after I solve that little equation, I get the value 4. Now at this point, what I'd recommend you do is you pause and you draw another column and you title that column a parenthesis, comma, parenthesis. This is really where we answer the question of how x relates to y. This is our way of notating that. We're going to draw our parenthesis, we're going to label our -2, and then we're going to label our answer that we got after we put -2 inside our function, which in this case equaled 4. And what we have as a result of doing this is a coordinate point. This is the key thing we need before we move on to step number 3. So let's do a couple more together, and then I'll leave the last 2 for you to do as well if you'd like to see for yourself how we generate that shape in number 3. But if I were to do -1 and 0, here's a little bit more quickly what I would be doing. I would ask myself, what does x equal? X equals -1. Fantastic. I'm going to write that straight in there for where I see x in my function. I see that it's squared, so I can't forget to square it. And then also, because we're in Math 125, we're learning some rules about negatives and exponents, right? So exactly like what I did in the row above, where we have the parentheses that are holding the negative and the 2, we want to make sure we keep doing that as we move down for this -1 as well. And -1 squared equals 1. And then again, we get a coordinate point when we follow through doing this. -1 for x, 1 for y, okay? And then we keep moving on. I'll actually finish out the rest of these for you to see very quickly. We'll see 0 squared, that equals 0. So we see another coordinate point show up as 0, 0. Doing 1 very quickly, I see 1. So I plug that into my function. 1 squared equals 1. So I see a y equals 1 as a result of that. I see a 1, 1 as a result. And then very lastly here, we'll plug in our 2. 2 squared equals 4. So we could just write the value 4 in there as well. We have a couple of options that we see for what you can put in that column. The important thing is to stay organized as you climb through making these points. So, okay, we got our final point here. This is great. We're ready for step number 3 at this point. And in step number 3, I'm going to go ahead and put this right below our table. And what you want to do is draw a simple x and y. Okay, so we're going to go ahead and draw our straight line down for our y-axis. We're going to draw a horizontal line for our x. It's wise to label these things, especially as we're learning these ideas early. And to build this graph, I'm going to consider the points that I just made in my table. I see that my points need to have a maximum y value of 4, because that's the highest number I see in my y value. And then the lowest value I see in my x value is -2. So it might be wise to give a couple tick marks accounting for that. And here's how I would do that. So I see the highest number in my y column. We can call this x and y for clarity. The highest number I see there is a 4. So I'm going to go ahead and do 1, 2, 3, 4. I'm going to give an extra 1 for 5. And then we want to make sure we do that down here as well. 3, 4, 5. And then we only had about 2 and -2 for our x range that we see these points plotting. I'm going to put a couple more ticks than that. We're going to do 1, 2, 3, 4. And then make sure you do the same thing on the other side as well. Okay, so at this point we have the backbone of where these points are going to go. Okay, these points live on this graph. And if we plot these points, kind of like Battleship, if you've played Battleship growing up at all, we see -2, 4. So I'm going to plot this point, and I'm going to use a lot of words to do this first one, and I'll let you see with the last ones where those would go. But I see -2, 4. Okay, so for my -2, it's going to exist -1, -2. It's going to exist right there. And then we have a y value of 4. So what I want to make sure I do is climb 1, 2, 3, 4. And that's where that point lives. Okay? -2 as a result of going 2 to the left in our x direction. And then 4, because it was a positive 4 value, it climbs up 4, is a way that you'll hear some people talk about how we plot those points. Okay, so the same thing is what we're going to do with the rest of these points. -1, 1, well, that looks like to the left 1 and up 1, okay? I see a 0, 0 show up. That's just straight in the middle. Don't forget the origin, the center, 0, 0. These things are similar language that we see when we're just trying to say in the middle of our graph. And then I see 1, 1. Don't forget these are 1, 2, 3, 4 positive as we climb to the right. So 1, 1. And then we also see 2, 4. So I go 2 and then up here to 4. All right. So in another color here, I'm going to really connect these dots. And if we did everything right, we're going to see a shape that looks pretty dang close to what we were saying earlier. Oh, okay. That does look pretty similar to what we saw in number 3 there. How did we get that shape? Well, remember, we started with our function. This function, and what I said at the beginning of the video that I wanted to convince you of, is that this function is the same thing as this shape for all x. This is a phrase that you'll hear when we're trying to communicate that this shape is that function. Now, if we only plotted 5 points, right? So if we were to try and draw this shape, it would only look like this, right? It would only look like a series of dots. So when we're trying to say y equals x squared for all x, we're imagining that we're filling in this input column with every number that we can think of. -3 lives on here, +3 lives on here. If we were to ask ourselves what this function equaled with that as an input, we would also see that show up somewhere inside our shape here, okay? So this is really important to understand because later on in the class, what we are going to be doing is trying to take some information from a quadratic graph like this. I didn't mention this word earlier, but this is technically a quadratic equation and a quadratic function. In another video, we can get more into detail on that. But what I wanted to accomplish in this video is really just, if you're not familiar with functions, if it's been a minute since you've been introduced to some of these math ideas, what I wanted to accomplish is introducing what a function is, maybe the difference between an equation and a function. Maybe that was a little confusing at one point. So we talked about how a function is really trying to get at how x relates to y instead of trying to solve for a value of x or solve for a value of y, like an equation would be asking you to do. And then we moved into a table view. We said there's another way that we can talk about a function. We can talk about it through building this table and getting a relationship of what x equals and what y equals and how they relate to each other. It's because we're able to describe this relationship, because functions are about relationships, it's through having these that we're able to make this shape. It's actually difficult until you get very good at identifying what these functions look like. You might not know what the shape of that function is supposed to be. So now you have a tool for how to get a visual of what that shape is if you're looking for a different function that doesn't quite look exactly like that. Well, that's about all the time we have for today's video. I hope this was helpful. Thanks again for clicking on Introduction to Functions, and happy studying.